Now here's a word problem that comes right out of your textbook. Let me read the problem to you. It's a car's radiator that contains 12 liters of antifreeze at 25% concentration. How many liters must be drained and then replaced by the pure antifreeze in order to bring the concentration level up to 50%? So we want to change the concentration from 25% concentration to 50% concentration. So we want to bring it to 50% concentration. Now, when I'm solving word problems of this type, I always like to work with some kind of a picture or some kind of a drawing of some sort. So I'm going to try to see if I can create a drawing that will help me to solve this problem. Now, what I'm starting off with is a container that contains 12 liters of antifreeze, and that 12 liters of antifreeze is at 25% concentration. And what I am supposed to do is to drain some of that out, and I don't know how much I need to drain out, so I'm going to drain out a certain portion of that, and so I'll use X liters as my variable. So X is the volume that must be drained out. And that volume, if we're draining it out of our radiator, then it's at the same concentration. So I'm draining out X liters of 25% concentration. And I'm going to replace that same volume of X liters, I'm going to replace that with pure antifreeze. And that pure antifreeze then must be at 100%. So I'm going to take out X liters of 25% antifreeze and I'm going to replace it with pure antifreeze, the same volume. And when I am finished replacing it, or when I brought the radiator back to its full level, the radiator will have 12 liters again. So we will end up with 12 liters, but this time we want the antifreeze to have a concentration that is equal to 50%. And so I want my concentration to be at 50%. So I'm changing it from a 25% concentration to a 50% concentration. Now I've got the picture drawn here, and from the picture it's going to be very, very easy to come up with the equation simply by looking at the relationships between all of these volumes. So we've got 12 liters at 25%, and we subtract from that X liters at 25%. And we add to that X liters at 100%, and we will end up with 12 liters at 50%. There's your equation. It's only got one variable, it's just got a lot of arithmetic in it, and it's very easy to solve this equation by using arithmetic. 12 times 25% is simply a quarter of 12, and so 12 times 0.25 is 3. So I'm going to have 3 minus X times 25% is 0.25 times X, and we have plus X times 100%, well 100% is just the number 1, 1X, so I'll use the coefficient 1, you don't have to, it's assumed or implied, and that's equal to 12 times 50%, and 50% of 12 is half of 12, so that's equal to 6. And that's a very simple equation. We can add these like terms. Subtracting a quarter X and adding 1X is going to end up giving us 3 subtract plus down 1 quarter and up 1 is going to be 0.75 times X is equal to 6. Now let's see if we can solve that equation for X. So carrying on then, we have we're going to subtract 3 from both sides of the equation, so 0.75 times X is equal to 6 take away 3, which is equal to 3, and so X is equal to 3 divided by 0.75, or 3 divided by 3/4. When you solve that, you will end up with X is equal to 4. So what's your conclusion? Your conclusion is that you will drain and replace 4 liters of antifreeze. So you're going to drain out 4 liters of the 25% antifreeze and replace it with 4 liters of the full concentration or pure antifreeze, and at the end you will end up with 12 liters of the 50% concentration.